So a polynomial function is a function of the form this. That's the one highlighted in green, where a subscript n minus 1, n minus 2 to 0 are real numbers. So the coefficients must be real number, not complex number. And the highest power, which is n, must be a positive integer. That's from 0 up. So the degree of any polynomial function is the highest power of x that appears. So the highest power is the degree. So look at this table. If you note that, if you look down, you will see fx. That's the first one. The degree is 0, because what we have is a constant, a subscript 0, which could be written as a subscript 0 x raised to power 0. So I'm saying that a 0 could be written as a 0 x raised to power that. So what's the degree? The highest power, which is 0. So the degree is 0. But if it's just a constant that is 0, we have no degree. What of this? The third row, as you can see, the highest degree is 1. So the highest power is 1, the degree is 1. The second one, quadratic, which is 2, power 2. So the degree is 2. So these are the names. 0 function, that's for a constant that is 0. Constant function for any other constant that is not 0. Linear function, and finally the quadratic function. So look at this example. As determine which of the following are polynomial functions. For those that are, state the degree. For those that are not, tell why not. So we're going to, so the first one is a polynomial function because the highest power is 4. Yes, as you can see, the coefficients are real numbers. So it's yes, it's a polynomial function. And the degree is 4 because the highest power is 4. Why the second one is not a polynomial? Because this is g of x equals 4 minus, we can write square root x as x raised to power half. In this case, half is not an integer, so not a polynomial, because the highest power is not an integer. The C part, I have hs equal to s squared plus 5 over x minus 1. This is not a polynomial. It's called a rational function. So not a polynomial function, because we are dividing a polynomial. But if you notice, the numerator is a polynomial by another polynomial, so which is not also one of the conditions for a function to be a polynomial. The D part is a polynomial, yes, because we can still expand this as minus 4x times x squared plus 6, yes, plus 9. So which is minus 4x cubed minus 24x squared minus 36x. So here the highest power is 3. So degree is equal to 3 because the highest power is 3. Why the last one is also a polynomial? If you could remember in the table, is a polynomial, but the degree a polynomial, but since it's a constant that is 0, we have no degree. It's a polynomial but no degree. If it's a constant that is not 0, 0 degree. Yes, but since it's 0, no degree, as you can see in the table. You see, so it's a 0 function, no degree. So we are on remainder theorem. Remainder theorem states that if f is a polynomial function and it is divided by x minus c. Then the remainder is fc. So whenever you're asked to divide a polynomial by a linear polynomial, the answer is the constant here, fc. So let's prove it. So if you have p of x and d of x are polynomials with d of x, x minus c, then there is this a unique polynomial qs and r such that this is just to tell us, whenever you're asked to divide something by, example, let me use the example. If you have 17 divided by 5, this 17 is the dividend, while 5 is the divisor. So that's what we are telling us. If p of x is the dividend and d of x is the divisor, so we know if you divide this, we have 3 whole number 2 over 5. Yes, this 3 is now the quotient. 3 is the quotient and 2 is the remainder. So that's what they are trying to tell us, that 17 is now equal to 5 times what? 3 plus 2. So do you see it? P of x is our dividend, 5 is the divisor, 3 is the quotient and the remainder. So if you have a polynomial, it's always like this. If you are dividing a polynomial by another polynomial, but in this case, the polynomial, that is the divisor, must be a linear factor, that is a polynomial of degree 1. So that if you have anything like that, the answer is f of c, the constant. So to prove that, we've known this from the basic. So what do? If you substitute x as c, that's our q of x. So remember, our divisor is x minus c. So if you substitute, this is the divisor, while this is the quotient. So though I interchange it so that it will look reasonable. So c minus c is 0, and 0 times that is 0. So you see that the remainder r, that's what is left. So r is now is the same thing as substituting x as c. So let me use the example to show you what I'm talking about. So if you're asked to find the remainder if this f of x is divided by this, so it's very simple. So for the first one, so they give us f of x to be that. So if we now substitute for this, that is, if f minus 1 equal to 0 implies that x is 1. So if you now substitute x as 1, you see that we have 2 times what? 1 cube minus 1 squared minus 3 times 1 plus 6. So we have 2 minus 1 minus 3 plus 6, which is, this is 1 minus 2, 4. So you see that the remainder that you get by dividing this by x minus 1 is 4. So that's the advantage of remainder theorem. You don't need to waste time using long division. So why this one? The same thing. If 2x minus 1 is 0, that's making x the subject of formula. X is half. Therefore, f of half is now, we substitute 2, 1 over 2 cube minus 1 over 2 squared minus 3 times 1 over 2 plus 6. So this is 2 times 1 over 8 minus 1 over 4 minus 3 over 2 plus 6, which is, this is 1 over 4. 1 over 4 minus 1 over 4 is 0. So we are left with minus 3 over 2, that is, let me write 6 minus 3 over 2 so that it will be easier. So this is 12 minus 3. 12 minus 3 is 9, so 9 over 2. So that's it. The remainder is 9 over 2. So that's what remainder theorem is talking about. That instead of wasting time, just substitute. As long as the divisor is a linear factor, that's a polynomial of degree 1. So thank you. So when g of x, as the polynomial, is divided by this, the quotient is that and the remainder is that. Find the values of p plus k. So this is a simple question because that requires the basic knowledge of polynomial. So we know that for every polynomial, let's call it g of x, that's the dividend, is always equal to the quotient times the divisor plus the remainder. Yes, this is the dividend, this is the quotient, this is the divisor, while this is the remainder. So every polynomial is like this. So they gave us two, so I said okay, let me just remove this. Therefore we'll have 2s cubed plus px squared plus qx plus 11 must be equal to, what's the quotient? X squared plus 5x plus 1 times the, okay, the divide, okay, no problem, you know it's commutative, so times 2x minus 5, so no matter what, product is commutative, plus what? 30x plus 16. So this is the remainder, this is the quotient, this is the divisor, this is the dividend. So with that, let's solve. So we have 2x cubed plus px squared plus qx plus 11. Why this will open up? This times this is 2x cubed. That same times that is 10x squared times that is plus 2x. So minus 5, multiply that, minus 5x squared minus 5 times that, minus 25x, and minus 5 plus 30x plus 16. So let's collect like terms here. Okay, let's add the terms, like terms, before we compare. So this is settled, there is no cube, so I have 2s cubed. Is there squared? There is squared, there is squared. So 10x squared minus 5x squared is plus 5x squared. So these ones are gone. Why is that? Okay, I have 30x minus 25x is plus 5x plus 5x plus 2x is plus 7x. So I think they are gone. Maybe let me use this so that we'll use red to know the ones. We are done with this. This and this are gone. This and this, 5x plus that 7x. So finally we have the constant, which is, or which are, that's minus 5 plus 16, which is 11. So this is plus 11. And if you look at the left hand side, they are equal, so you compare. I'm seeing 2s cubed, I'm seeing 2x cubed, I'm seeing 11, and I'm seeing 11. Therefore p is the coefficient of s squared. P is 5 and q is 7. Therefore p plus q is 12. Nice question. Thank you. Okay, they said the polynomial b is divided by that. The remainder is 7. So using remainder theorem, we know that if this is the polynomial, let's call it f of x, equal to 4s cubed plus as squared plus 7x minus 23. Then if this is equal to 0, because we are trying to get the remainder, so you equate the divisor to 0 as long as it's a linear factor. We now have that x is 5 over 2. Therefore, from the remainder theorem, f of 5 over 2 must give us 7. Yes, if you substitute this, must give us the remainder. So we have that this is 4 times 5 over 2 raised to power 3 plus 8 times 5 over 2 squared plus 7 times 5 over 2 minus 23. So let's see, is equal to 7. Let's see what we get. This is 125. That's 25. 125 over 8, which is 125 over 2. 4 and 8, that's it. So this is 25 over 4. That is 25 over 4a. While this is 35 over 2 equal minus. Okay, let's move it. So it's now equal to 30. I moved minus 23 to the other side to be plus 23. So we're looking for that. So let's clear the fraction by multiplying by their LCM. LCM of 2, 4 and 1 is 4. So 4 times 125 over 2 is 125 times 2 is now 250. Why this times 4 is 25a. We have 25a plus 4 times 35 over 2 is 70. 4 times 30 is 120. So we're still on the. So we have 250 plus 70. So we have 25a equals 250 plus 70 is 320. So 120 minus 320. So this is minus 200. Yes, this is 25a. So a is now minus 200 over 25, which is, we'll divide both sides by 5 can go. So 5 in that is minus 40. 5 in 25 is 5. So that is minus 8. So the answer is A is minus 8. So it's a nice question, option B. Thank you. So we are given this from our remainder theorem. We know that if we have a polynomial fx, let's call this first one fx to be equal to x cubed minus 2x plus a. And let's call g of x to be 2x cubed plus x minus a. So from the remainder theorem, the remainder is the same as substituting because this is the divisor. If x minus 1 equal to 0 implies that x is 1, and also if 2x plus 1 equal to 0 implies that x is equal to minus half. So we now substitute these two values in that. So if I want to get the remainder when it's divided by this, I substitute x as 1. The value is the remainder. Also, if I want to get the remainder when g of x is divided by 2x plus 1, we have the same remainder. We have that f of 1 is equal to g of minus half. Yes, that's 1 raised to power 3 minus 2 times 1 plus a is the same thing as substituting this, which is 2 minus half raised to power 3 plus minus half minus a. So I have 1 minus a, so I have a minus 1 because this is minus 1, so a minus 1. Why this is minus, this 1 minus 1 over 8, that's minus 1 over 4 minus 1 over 2 minus a. So we collect like terms. A goes here to be plus a, so a plus 1 goes to be 1. This is minus is 1 over 4. Therefore, A is now 1 over 8. So our answer is option C. It's a very tricky question. Thank you. So we're on factor theorem. So the factor theorem states that if f is a polynomial function, then x minus c is a factor of f if and only if f of c is 0. So we are saying that if you notice this is a linear factor, that if you substitute c in the polynomial and the remainder is 0, because f of c is also the remainder. If you get the remainder as 0, then is a factor. From our normal sense, if something is a factor of something, means that if you divide it, it will give you no remainder, as the remainder is 0. So let's look at this question. They say use the factor theorem to determine whether this function has the remainder, has the factor as x minus 1 and also x plus 1. So let's check. So if the remainder is 0, you know that. So if we substitute, if for the first, if x minus 1 is 0, that's substituting x as 1. So then let's check f of 1. We have 1 cube 2 times 1 squared minus 5 times 1 plus 6. So this is 1 minus 1, so it will give us 0. Yes, this is 1 minus 2 minus 5 plus 6. Yes, 1 minus 2 is minus 1. Minus 1 minus 5 is minus 6. So this is 0. So it's a factor. So this is a factor. So let's test the other one. If x plus 1 is 0, then x is minus 1. So if I substitute f of minus 1, let's see, minus 1 cube minus 2 times minus 1 squared minus 5 times minus 1 plus 6. So this is minus 1 minus 2 plus 5 plus 6. I think we're okay. That's plus 5 6, that's 2 minus 1. So let's know whether it's a factor. This is minus 3. Minus 3 plus 5 is 2. So we have 8. We have 8. So not a factor. The remainder is not 0. So not a factor. So that's all about factor theorem. So once you substitute the value of c, remember it must be a linear factor. Must be a polynomial of degree 1. If you substitute and the answer is 0, you know that is a factor. Thank you. So they said if this polynomial is divided by this polynomial, and if when divided by this, that is divisible by that, and this when divided by the remainder is to find the constant. So we're going to use both remainder and factor theorem here. So let's call the polynomial f of x. Let it be. So this is x raised to power 4 minus k times x raised to power 3 plus 10x raised to power 2 plus lx minus 3. So if for this to be for this to be a factor, that's for it to be divisible, if x minus 1 is 0, implies that x is 1. Therefore, if we substitute 1, the remainder is 0. Yes. So for it to be divisible, so let's substitute. We have 1 raised to power 4 minus k times 1 raised to power 3 plus 10 times 1 raised to power 2 plus l times 1 minus 3 must give us 0 for it to be the factor, for it to be divisible. So we have 1 minus k plus 10 plus l plus minus 3 equal to 0. So we are forming a simultaneous equation. I have L minus K. Do you get? This is L minus K. 1 plus 10 is 11. 11 minus 3 is 8. So we'll move to that to be minus 8. We'll call it equation 1. So that's our equation 1. So they said again, the remainder is 27 when is divisible, when is divided by x plus 2. So if x plus 2 is 0, it implies that x equal to minus 2. So if you substitute f as minus f of minus 2, if you substitute x as minus 2, it must give us 27. That's remainder theorem. Why we used factor theorem, the other one, the remainder is always 0. So we substitute. I have minus 2 raised to power 4 minus k times minus 2 raised to power 3 plus 10 times minus 2 squared plus L times minus 2 minus 3 must give us 27. So I have this 16, that's 4 squared or 2 raised to power 4. Why this is minus a, so plus 8k. This is 4, so plus 4, 40. This is 2l minus 3 equal to 27. So again we'll collect like terms. So L, so I have 2l minus 2l plus 8k, 16 plus, okay, let me do it this way. Minus 3 goes over to be 3, so 30. 30 minus 40 is minus 10. Minus 10 minus 16 is minus 26. So we'll divide. Something can go. So let's divide by minus 2. I have L minus 2 minus 4k. So I divided by minus 2. Divided by minus 2, 13. So equation 2. So we solve equation 1 and 2 simultaneously and by elimination. So if we now do equation 1 minus equation 2, we eliminate L. L minus L gone, minus k minus minus, so we have 3k. Y minus 8 minus 13, I have minus 21. So what do you have to say? K is minus 7. That's minus 21 over 3. So we choose any of them and substitute the value of k. So from equation 2, from equation 1 is better. We see that L will be k minus 8, which is minus 7 minus 8. So L is minus 15.
Polynomial division. Before we do this polynomial division, we need to recap our long division because that's what we are going to use here. So example, if someone asks you to find the quotient and the remainder of maybe 948 divided by 3. So how do you do it? It's very simple. We'll place the divisor, which is 3 here, and 948. So we'll start with 9. 9 divide 3, you have 3. We'll place it directly above 9. So 3 times 3 is 9. We subtract. We have 0. So each time you finish, you bring out the next digit, which is 4. So 4 divided by 3 is 1. 1 times 3 is 3, which is 0, 3 now. we subtract, we have 1. Finally, we bring down 8. So 18 divided by 3 is 6. 6 times 3 is 8. So we now see that this is the quotient, and this, the 0, is the remainder. So let's move one more before we go to polynomial division actually. So we asked to find the quotient and the remainder of 2, 3, 5 divided by 4. So we'll start again. 4 here, 2, 3, 5 inside. So we'll start 2 is less than 4, so we'll start with 23. So 23 divided by 4 will have 5. We'll place directly above 3. So 5 times 4 is 20. You subtract. So I have 23 minus 20 is 3. So bring down 5. So 35 divided by 4 is 8. 8 times 4 is 32. We subtract. So our answer is, the remainder is 3. While the quotient is 20. So with that knowledge, let's do the division of polynomial. So look at it, we have to find the quotient of this. So write solution. So I write the dividend, which is minus x cubed plus 10x squared minus 15x minus 3. Why the divisor? X minus 1. So we divide minus 7x cubed by x. We get minus 7x squared. We now multiply, we use it to multiply the numbers here. So minus 7x times x, I have minus 7x cubed minus 7x squared times that, I have, that should be plus 7x squared. So we subtract. So this minus this is 0. 10x squared minus 7x squared, we have 3x squared. So after that we bring down minus 15x. We start again. So 3x squared divided by x is plus 3. It's now minus 12x. So the next thing we'll bring down minus 3. So we'll now do minus 12x divided by that, we have minus 12. So minus 12 times x is minus 12x. Minus 12 times that is plus 12. So we'll subtract. So we'll continue. This minus this is 0. Minus 3 minus 12 is minus 15. So that's our remainder. And this is our quotient. So our answer is option A. So that is it. Let's find the quotient and the remainder of this divided by that. So we use our long division method. So we'll place our dividend inside. But while placing, if you notice, the highest power is 3 and we have a constant, so we need to write the coefficient, that's decrease down to avoid making mistake. It will guide us. So whenever you are asked to divide a polynomial and you notice that the polynomial, that's the dividend, doesn't decrease down to a constant, you have to write the coefficient 0, so it will aid your solution. So this is 7x squared plus 3x minus 12. So we'll start. The first value here divided by this, so 7x cubed divided by 7x squared, we have x. So we use this x and multiply all through. So x times that, we have 7x cubed, x times plus 3x is plus 3x squared, x times minus 12 is minus 12x. So each time you subtract. So 7x cubed minus 7x cubed is 0. 0 minus 3x squared, 0x squared, or 0 minus that is minus 3x squared. Why 0 minus that is 12 plus 12x. So each time you subtract, you bring the next number, which is plus 1. So we'll start again. Minus 3x squared divided by 7x squared, we have minus 3 over 7. Minus 3 over 7 times that, we have minus 3x squared. Minus 3 over 7 times 3x is minus 9 over 7x. 1 minus 3 over 7 times minus 12 is plus 36 over 7. So each time you subtract. So let's subtract. So this minus this is 0. 12 minus 9 over 7. 12x minus 9 over 7x is 10. 12. 7 times that is 84. 84 plus 9, that is 93 over 7x. While 1 minus 36 over 7 is minus 29 over 7. Okay, so we'll stop. Yes, because the highest power here is x, while the divisor, the highest power is x squared. So this is less than this. So our answer, this is our quotient. Why this is our remainder. So that is our answer. So it's a very nice question. Thank you. Okay, welcome back. We're on synthetic division. Synthetic division is just a quick method of dividing polynomials. It is used when the divisor is of the form x minus c. Yes. So if you have a linear factor like this, x minus c, a polynomial of degree 1 with coefficient, if you take the coefficient of x is 1, that's when we use it. To divide this polynomial by this linear factor, we proceed as follows. So I'm going to do the algorithm of synthetic division. So what do you have to do? What is here is minus c, so we'll write positive c since it's minus c. So whatever the sign here, you change it here. We write the coefficient of the polynomials, the coefficient of the terms. So we shall a subscript n minus 1, a subscript n minus 2. So that's how we write it till we'll get to the last one, a1 and a0. So as you can see, we've written the coefficients, and I told you the sign here is negative, that's why we wrote positive. So the first step after writing this is to bring down this coefficient here, which is a n. But in terms of, because of our solution, I will write it b, because if you look down, I wrote b subscript n minus 1 is equal to an. So let me write it. They are equal. So formally in the solution, what we write is an, but in terms of this algorithm, so let's write it b subscript n minus 1. Yes, which is the same as an, just means bring down an, but let's call it b subscript n minus 1. So the next one is to multiply this c by b subscript n minus 1. So if you multiply it, we have so if we multiply c by b subscript n minus 1, I have c b subscript n minus 1. So whatever that I get, which is c times b subscript n minus 1, you add it to the one up. So if we add, let's assume that the sum is b subscript n minus 2. So again we'll do, so c will be multiplying the ones down. So c times this b subscript n minus 2 will get b subscript n minus 2. We add again, assuming we get b subscript n minus 3. We multiply. So that's how we do it. We do it till we get to c times b subscript 1. If we add it, we have, maybe let's b subscript 0. We now multiply, we have c times b subscript 0. So we add, we now get r. This r, the last term, is the remainder. So that's it. So why the ones here aside the last term are the coefficient of the quotient. As you can see, the remainder is r and the quotient is now this. Yes, it will be 1 down since we are dividing by a linear factor. So it will be 1 down. That's why we have n minus 1 here, n minus 2. Do you get? We factored 1, so the power, the highest power of the quotient will be a power less than 1. So let's look at these equations to see what is happening. They say find the remainder and the quotient when this is divided by that. So it's very simple. We'll write the coefficient. I'm using that algorithm now. Write the coefficients. So what is here is the coefficients here 2, minus 1, minus 3, and 6. So we'll write what is here is minus 1. So I write plus 1. You count. So we'll bring down 2. 1 times 2 is 2. You add. If you add, I have 1. 1 times 1 is 1. If you add, you have minus 2. 1 times minus 2 is minus 2. If we add, we have 4. So this 4 down. Why this is the coefficient of the quotient, which is the constant, the coefficient of x and coefficient of x were therefore the quotient is 2x squared, because I told you it will be 1 down from that, minus, that's plus, because what is here is plus 1, so plus x minus 2. The remainder is 2, is 4. So why the second one is a? The same thing, we write the coefficients of the dividend, which are 2, minus 1, minus 3, and 6. So next thing is to write this plus 2, I write minus 2. So bring down 2, multiply minus 2 and 2 is minus 4, add minus 5, multiply 10, add 7, multiply minus 14, add minus 8. So what do you say? Minus 8 is the remainder. Why this is the coefficient of the quotient, therefore the quotient
is 2x squared minus 5x plus 7. So it's a faster way of dividing polynomial to get the quotient and the remainder. Zeros and multiplicities of a polynomial functions. So if f is a polynomial function and r is a real number for which f of r is 0, that is, if you substitute f of r and you get 0, then r is called a real 0 of f or root of f. So if you don't call it real zeros, we'll call it roots. And also, if r is a real 0 of f, then must be an x-intercept, that it must cut the x-axis. And also, x minus r is a factor of f. So once we have r as the real 0 or the root, then r must intercept the x-axis, and also x minus r is a factor of f. So we look at this. Also, if x minus r raised to power m is a factor of a polynomial function f, and s minus r raised to power m plus 1 is not a factor of f, then r is called a 0, that is a root, but it has a multiplicity of m. So I'll use this example to explain. So from here, we'll see that the root, as you can see, we have x minus raised to power s plus 1 raised to power 3, s plus 8 raised to power 4. So what is m here? 2. So the zeros now, so the zeros here, I'm talking about the first one. The zeros are 1, minus 1 and minus 8. While the multiplicity is now the powers. So for the first one is 2, power of 2. The second one 3, third one 4. So that's it. So for the second one, they didn't factor it, so we need to factor it. So what is common? We bring out x. I have x plus x squared plus x minus 12. The multiplicity, they are all 1. So the zeros are minus 4. The zeros are 0. Sorry, because I didn't consider the 0. Because this x, we can write x as x minus 0. So from here, this is also minus 4, and this is also 3. Do you get? Just the opposite sign. So the zeros are this, while the multiplicities are all 1. 1. So they all have 1 as multiplicities. The multiplicity of a 0 of a polynomial could be even or odd. It is even if it touches the x-axis, but odd if it crosses the x-axis. As you can see, the first one, r1, is r subscript 1. It crosses the x-axis, so we have odd multiplicity. So for this is also odd. R2 is also odd because it crosses this R2. So why this is even? Because it touches, as you can see, at R subscript 3, it touches. So this is even multiplicity. Why this one crosses again? This will have odd multiplicity. So that's it. So that's how we know when it is the power is even. That's what I'm saying. The factored power is even or odd. So it will help us to sketch the graph, or maybe draw the graph if we are asked to draw it. So look at this. They say identify the points where the polynomial function crosses or touches the x-axis. So the first one, let's group with even and all this even multiplicity, and we have odd. So for the first one, which of them is even? So I have 2 is even, so it will do what? Touches here, touches at 1, and which one again? And -8. Do you see it? Because we have even multiplicity, so it will touch at 1 and -8. Why odd? It crosses at -1. So that's for the first one. The second one, we need to factor first. So let's factor this. This is x times x squared plus x minus 12, which could be written as x times x plus 4 x minus 3. So the powers are 1 1 1. So here the even, as you can see, we don't have even, none. Yes, because they are all 1 1 odd. So we have what? 3. So it will cross. So crosses at 0, -4 and 3. So that's it. Which of the following is the graph shown? So the first thing I have to note here is that I've done it before in my previous video, that if you have a polynomial function x plus maybe k1 raised to power m1, x plus k2 raised to power m2, and so on. Okay, let's just write x plus k3 raised to power m3. That's the graph touches if m1 is, that's if m, whether m1 or m2, and if m is even, and crosses if m is odd. And it will now whether touches or crosses when x is equal to minus k, whether k1, k2, k3. So looking at this, we're going to use the knowledge to know which of them. And again, remember because I'm seeing the x saying, okay, let's just continue. Let's do this before we get to that. Looking at this, which of them is even? If you look at 2, it touches. So meaning that the power of 2, that the power of factor x minus 2 must be even. Yes. So which of them is x minus 2 even? So this is off, because here x plus 2, but it should be minus 2, because if you compare, this plus k1, so if you equate it, minus k must be x equal to minus the negative of the constant here. So it should be minus 2 for it to be 2 here. So this one is off. And if you look at the second 0, that's where it crosses as x equal to 1. So which of them, that if you equate this x equal to 1, that is equal to 0. If I equate whatever that is in the bracket equal to 0, that's how we got x equal to minus k. Equating this, it equal to 0. So make as the subject of formula. You see that we get x here 1. We also get x here 1. We also get x. So we can use it. And the third one crosses at minus 1, meaning x plus 1 is a factor. So meaning this is off, because what we have here is x minus 1. It should be x plus 1, so that if you cross it, see, you know why now, is an odd power, so that's why it crosses. So this one is off, remaining these two. So how do you know which one is correct? We now use extra knowledge, the x and y intercept. Okay, we've used x intercept, that's the roots are all x intercept, so we use what? Y intercept. And what is y intercept? When x is what? 0. So we substitute here to know whether we'll get 4. See, y intercept, this is y intercept. So if you substitute x as 0 to know which one will give us plus 4. So substituting this is as 0, this is 0, this is minus, this is 4, 0, 0. So minus 4 times 4 is minus 4. So this is off. I think this is the answer. Because if you see this is 4 times 1 times 1, which is 4. So this is the correct answer. So using y intercept, so that give us the correct answer. Our answer is option B. So that's it. Ask which of the following is the graph shown. So as you can see, that's a polynomial function because it's smooth and continuous. It's a polynomial graph. And if you have a polynomial fs equal to, if you factor it, x plus maybe k raised to power m, k1 raised to power m1, s plus k2 raised to power m2, till maybe any, okay, let's just use 3, k3 raised to power m3. So if you have a polynomial factored this way, it touches the x-axis if m is even. So it will touch the x-axis if m is even, or crosses s-axis if m is odd. So it will cross if it's odd, and both of them crosses or touches at x equal to minus k, whether k1, k2, that's equating this to 0. So let's use that knowledge here. Looking at this, we see that at the x-axis they crosses, so meaning that the power, all their powers must be odd. Yes. So what are we trying to say? That this is off, this one is off, because we have power of 2 even. So any other one, no. So we are done. We've eliminated D. Again, remember, this must be 2, 1. So okay, look at this. If you equate this to 0, we'll get 2. Okay, it's okay. If we equate this, we get minus 2. Is there roots, any root of 0 that is minus 2? No. So this one is off, because this is not a factor, x plus 2. If you equate it to 0, you get minus 2, but none is minus 2 here. So coming to this, remaining 2. How do you know which one? So we use the next option, which is the y-intercept. Are you seeing y equal to, this is the y-intercept, meaning x is 0. So what do we do now? We substitute the value of x to be 0 to know whether we'll get minus 2. So using y-intercept, so the next thing is to use y-intercept, meaning x is 0. So let's substitute x is as 0 in all the remaining one to know whether we'll get minus 2. So if we substitute this 0, 0, 0, so I have minus 1 times 1 is minus 1. Minus 1 times 2 is minus 2. Minus 2 times the minus outside, we have plus 2. So this is off. We got plus 2. So but if you substitute, I have minus 1 times 1 is minus 1, minus 1 times 2 is minus 2. So this is the only answer. So that's it. We'll first check the multiplicity, that's the power, the factored power, the power of the factored linear factor. We first look out for the power, whether it's even or odd, to know whether it will cross or touch. And we now use our intercept, y-intercept. Remember, it seems what we used here is even x and y-intercept, because at this point y is also 0. So the major thing in graphing is x and y-intercept. So that's it for thank you. Okay, welcome back. So we'll be analyzing polynomial graph. So we have two graphs here. One is a polynomial while the other one is not a polynomial. So generally, a polynomial function, the graph is always smooth and continuous. Yes, as you can see, the first graph, graph A, is always smooth and continuous. But if you look at the second one, there are some discontinuity, like there is a hole here, which is a form of discontinuity, and also you see gap, and you also see a kink. So this is not a polynomial graph, so not a polynomial. Why this one? The first one is a polynomial because it's always smooth and continuous. So once you see a polynomial graph, you will know. So let's now look at what we call a power function. This is a special type of polynomial function. So we call it power function. So generally we have two graph of power function. So one is when it is greater than, that's when the power, that's what power function is, any function of the form y equals x raised to the power n. So this is a power function. So it depends. If n is an even number greater than or equal to 2, we have the first graph. I'm saying that whenever you have, as you can see, where n is greater than or equal to 2, so we have either concave up, as you can see, or concave down. So one is when the coefficients, that's if you, okay, let's put coefficient. So one of them is when a is greater than 0, that when it's positive, y1 when it's negative. So again down here, this is when n is greater than or equal to 3. So when you have n greater than or equal to 3, the graph is either this one or the other one. So for this first one is when the coefficient is positive. So we have this graph, this power graph, power function. This is when a is positive, but this is when a is negative. So let's look at this. Okay, let's look at this. Okay, we'll see that the first one is when that this is when n is greater than or equal to 2, that's even. Why this is when n is greater than or equal to 3, that's odd. So look, you can see we have 4 graphs. One is y equal to x raised to the power 4, the other is y equal to x raised. You notice that since both of them, the coefficient is positive, that's coefficient, they have 1 as coefficient, positive 1, so that's why it's concave up. But you notice that the one that has the higher power sits on the x-axis. If you notice, it sits on the x-axis. That's the blue graph. While the red one is somehow off from the x-axis. So the higher the power, it sits more on the x-axis. While the other two, almost the same thing. When n is greater than or equal to 3, you see that we have what? Do you see as before? The red one, that's 3. But if it's negative x raised to power 5, you see that it does what? Sits more on the x-axis, as you can see. So that's what I'm saying. Okay, let me just, maybe you'll be confused. See what I'm saying? Assuming this is a power function, this is when x, this is, let's take it as x raised to power 3. The coefficient is positive, that's why it's like this. If I now sketch another one, okay, let me use another. Look at this. This one sits more. It sits more. So this one, the orange one, will be raised to power. That's a power greater than 3, but it's an odd power. So maybe let's take 5. So the higher the power, it sits more on the x-axis. So that's what I'm trying to say. That's the graph here. So let's sketch this. Okay, like for example, we have to sketch this graph. Before I do this, let's revise something we know before. Graph transformation, because we are going to transform this graph. Graph transformation. So assuming we have a parent graph, maybe you have something like, just let's use any graph. Maybe this is the parent graph. So we'll transform by shifting to the left, to the right, up and down. So assuming this is fx. So if I want to transform this by shifting up, so assuming this is the original vertex. So if I shift up, what do I have? Maybe if I shift up, so this graph, if this is this one, the one shifted up, the graph will now be, I'm saying this, if we shift this graph up, so whatever that we'll get here will be the original function, which is fx plus k, assuming we shifted k units up. But if it's down, that same function but you shifted down, we now what we have is minus k. So up is plus, minus is down. So again, if we decide to shift that same graph to the left or to the right, so I shift maybe to the, I shift to the left, or I shift to the right. So assuming this is f of x, this green one is f of x. If this one is f of x, the one here will be fx minus, assuming you shifted k units, maybe from here, so it's now f minus k, f of x minus k. But if you shift from here to here, that same k units to the left, it will now be f of x plus k. So that's graph transformation, because we're going to use it here. So for the first one, we have, look at this. So we are given the first graph. Okay, let me just copy. As for the first one, I used app so that it will be easier for us to see. That's the first one. We see that we have two graphs. One is the parent graph. Yes, this first one, as you can see, that's the parent graph. Remember, when the coefficient, because we can write this as minus s raised to 4 or 7 plus 2. So the coefficient of x is negative. That's why it's like this, the shape. If it's negative, it will be the other way around. So, but we now shift this parent graph up by 2 units. So do you see it? We now move up, assuming here is 2. So that's the next graph. So we'll move 2 units. So that's it. So we'll sketch the first one. Why the second one? We start with the parent graph, which is x raised to power 6. As you can see, it's sitting on the x side because the power is somehow large. So this is the first graph. We now transform, we'll move to the right, minus 2. So we'll move 2 units to the right. You see it? So this 2, the gap from here to here is 2. That's from here to here is 2 units. So finally, we'll multiply by half. Okay, I didn't say anything on multiplication. If you multiply by a constant, that's okay. Let me just do it here. Assuming you have a parent graph, you have this is a parent graph, y equal to fx. So if you now multiply by a constant, it does something to it. It's either it widens or it comes closer to the y-axis. So it's either this one, the pink one, or maybe let me use another ink. The pink, and let me use yellow. So it's either this pink one or the orange one or the yellow one. So it depends on the constant. The pink is when the constant, that's if you have y equal to k times fx. So this is when k is greater than 1. Are you following? So if it increases, if the power is number is greater than 1, it will be coming closer to the y-axis. But this orange one, or this is when k is less than 1. So it will be widening. So that's why we multiply it by half. If you check, this one is wider. The last one is wider than the second to the last. So that's why it was multiplied by half. Okay, that's for power function. So the end behavior focuses more on the highest power, that's the highest power n, and its coefficients. So this determines the behavior, how the graph will look like, especially the end parts. So for the first one, we have that when n is greater than or equal to 2, as you can see, the end, let me change the color. So this is when n is greater than or equal to 2, meaning all even numbers greater than or equal to 2. So the end behavior, the graph will end like this if the coefficient of x raised to power n is positive. So this is when an is greater than 0. So if it's positive, the graph will end this way. But if it's negative, it will end this way. So why the last two is when n is an odd number greater than or equal to 3. This is when n is greater than or equal to 3 and is an odd number. So if an is greater than 0, it will end this way. So that's how it will end. But if it's less than 0, it will end this way. So it's very, very important. We are going to use it later. So look at this. There's what we call maximum number of turning points on a graph of a polynomial function. So if f is a polynomial function of degree n, then the maximum number of turning points is n minus 1. So we're saying that if you have a polynomial of degree n, that's the highest power of x, to get the maximum turning point, how many times it will turn? You subtract 1. So let's look at this example. They said we should find the maximum number of turning points of the following. So for the first one, the degree is n is 2 plus 3. Yes, you add the powers. That gives us the degree. So the degree of this is 5. Therefore, the maximum number of turning points is now 5 minus 1, which is 4. So if you grab this, it will turn at most 4 times. So why the second one? N is 3. Yes, because the highest power is 3. Therefore, the maximum number of turning points will be equal to 3 minus 1, which is 2. So if you grab this, it will turn at most 2. So let's combine this, the knowledge of n behavior and maximum number of turning points, to solve these two equations. So they said, which of the following is the graph shown? So it's a tricky question, but it's still simple. Yes, it's simple. So we are given this graph. So the best way to solve this is use the knowledge of n behavior, maximum number of turning, because we are not given any roots. We are not given any roots. No s-intercept. So as you can see, the n behavior ends here and here. So what do you notice? From what I say, the n behavior here, it must be even. The power must be even, greater than or equal to 2. So we have an even function. So our graph, the highest power must be even. So which of them that the highest power is even? We have 3. So this is off. So, and how do I determine, what will I do again? Okay, using the turning point, the maximum number of turning points, you can see that it turns 1, 2, and 3. So what do you have to say? N must be what? The degree. N must be 4. Yes. For it to have 3 turning points. So which of them has 4? Also 3 of them. And again, do you remember that it turns down? So it shows that the coefficient of x raised to power n must be negative. As you can see, let's go back. Do you remember? They say that n must be less than what? 0. It will be this. So this is the second graph. The graph will look like this. So in this case, the coefficient of x raised to power n must be negative. So let's go back. So which of them is the coefficient negative? Okay, I have to. So this is off. This is positive. If it's positive, both of them will turn off. So remaining these two, how will I know which one is the actual answer. We now use our extra knowledge, the formal knowledge we know from the beginning of graphing of any function, the x and the y-intercept. Yes, as you can see, I'm seeing y-intercept 2, meaning if I substitute x, so using y-intercept, meaning x is 0. So if I substitute x as 0, if I get 2, means that's the actual graph. So if I put 0 0 0, so this one is off because it will give us -2. So the answer is this. So the answer is option A. So let's look at the second graph. Which of the following is the graph shown? As you can see, you see that the turning, the maximum number of turning points. Okay, let's start with that. We have 1, 2, 3, 4. So meaning n must be 5. Yes. So this is off. So, and again, if you look at the n behavior, it faces down here and faces up. So what do you have to say? Remember, we have 4 categories. So